Hello everyone, welcome to another problem session. Currently we are doing Indian JEE 2024 Advanced Physics Paper 1, and so we are up to question number 15, and this question is actually very instructive. Okay, so you can maybe do it kind of a wish way, or you can do it fundamentally. Let's do it fundamentally, okay? So this question about getting capacitance between different points, different metals. So if you have a metal and another metal, just say in general. So you want to get a capacitance of this arrangement. You'll put some charge plus Q on this, and you put minus charge, extra charge on this. So they have a plus Q and exactly opposite charge over here. Let's say this is a plate just like this, okay? You just two of them. Then how do you go about getting the capacitance of this? Okay, the way to get it is find electric field in this area, and say from point A to point B, you can integrate electric field. So V will be minus E dot dl. So you take a maybe straight path like this and integrate on it. In this situation, you're going to get all constant electric field. So after you integrate, you are going to get answer will come out as proportional to Q, and there will be some blob here, and then you can identify this as Q over C. Then C will be simply 1 over that blob. That's what the capacitance is. Okay, that's how the fundamental difference capacitance is. So we're going to do just that way here, and we're not going to try to guess which is parallel and which is in series. And I know you can do that, and you can very easily fool yourself when you're doing that. All right, you just have to see how the charges will distribute, and just do it this way. So let's do P, for instance. So if I do P, so there are these 4 situations here. There are 4 different problems, and they have some possible answers. For P, it can be 3 or 2. The 3 choices are 3 and 1 choice for 2. So if you get a P equal possibility 2, you are done, right? There's nothing more to do. That just eliminates it. So obviously that's not going to happen in a problem. So, but we want to do P, all right? So what it is between S1 and S4 with S2 and S3 not connected. So we have a plate, and of course we have plate has 2 sides, and we have 2 sides, and they're all equal distance. Okay, so if you put a plus Q on this side and minus Q, they'll face each other, and they will pull. This side will become minus Q, induced minus Q. This will be induced plus Q. This will induce minus Q. This will induce plus Q. So you can see in here, in a parallel plate situation, if you have a sheet of charge Q, and let's area be A, then electric field here is going to be Q over A or 2 epsilon naught from this plate. And electric field from this charge will be exactly same. Electric plus will be like that, minus will. this is going left to right, and this also be Q over A to epsilon naught, and it's still going towards the right, towards this plate. So if you have equal charges like that, then what you expect here is Q over A epsilon naught, adding these two together. And when this is constant, then if you integrate between here to there, you are going to get this times the distance. But we're supposed to get from here and here. So my point is A here and B point here. So we will take a path from A to B like that. So we have to integrate up to here, and the inside is 0. Inside the plate is 0. Inside is 0. Okay. So when you do integrate A to B, let's call it, you can say R1, R2, R3, R4. So you'll have A to R1 to R2 to R3 to R4 to B. And then clearly you're going to get from here is going to get a, so when I do E dot dl, I am going to get from here, I'm going to get Q over A epsilon naught. From here, I'm going to get exactly same quantity, Q over A epsilon naught. I'm going to get Q over A epsilon naught. And D and the D and the D was missing when I integrate dl. Okay. Doing this gives me gives me Q times 3D over A epsilon naught. So this is the blob. You are going to get a plus or minus depending on which way you choose, right? So I do this integral to get a delta V. Or you can do integral from negative to positive. So the direction does matter. For electric field is towards the negative. If you go from positive to negative, this you'll be going the same direction. All right, so you get 3D epsilon naught. So inverse of that, so C in this case will be A epsilon naught over 3D. And this part they're calling C0. Okay, so C0 over 3. So C03 is this choice. So this, not that. So those are the P values. That's okay. Now we can do Q. Let me erase this so I can get more space for doing Q. Okay, so for Q, once again we put a plus Q here and minus Q here and see what happens. It's gonna, let's just plus Q over here. It's gonna pull. Now this whole thing is 1 unit when you connected it. Over in the P there are 2 different pieces. Now it's 1 piece, so it's gonna pull out minus over here, and this is going to be on this surface minus Q, and on all of this will be uncharged. On this surface will be plus Q, and this is minus Q. Now again I'm going to have to integrate from here all the way here. And this is the metal, so electric field here is, electric field is 0. Electric field is 0. Electric field is 0 here. So only electric field is over here and over here. And each one of them is, electric field is pointed that way, and Q over A epsilon naught. But half of that comes from these charges and half that comes from these charges, just previously explained, right? So V is actually positive minus negative is called V. So if this is the voltage that potential difference is going to get from point A to point B. So if I do from point A to point B, if this is a positive and this is negative, so this you are going to get a negative, okay, negative voltage here, because we are it's just which side is higher. This side will be higher than that, and if I integrate it from this to that side, I will get a positive value. So if you want to, so you integrate from negative to the positive, then all the signs will be just positive, okay? But I'm not going to worry about sign and just ignore it. And all right, so I hope you understand the sign. You can make it consistent. Okay, so A to B, and I'm going to get a sigma. Sigma is Q over A, sigma over epsilon naught, dl. Sigma is Q over A, and dl will be from going A to R1 and then R2 to B. So A to R1 will be that. Then you're going to get all zeros minus B R2 to B Q over A epsilon naught dl. So both of them are equal. So this time I'm going to get C is C0 over 2. Okay. And so Q will be 2. So I rule Q will be 2, Q is 2, Q is 2. I doesn't really change anything by doing Q. I think this was a little bit waste of time. You know, in the exam situation, I should have realized doing Q doesn't help. Okay, we've done the Q, and then do the R. Okay, so to do R, we're going to look at the plates as follows. So it's between S1 and S3. So S1 and S3, they will have charges spread on them because they're not connected to any other plates. And then we have S2 and S4 are just shorted. And there are two surfaces where the charge can spread. So this is a plus Q and this is minus Q. We place on them. So this will induce, in the whole thing is going to induce minus Q. So just this one induce minus Q, pull it here. But this minus Q will have to be spread on two surfaces. So, and this will pull this side plus Q. And this plus Q will have to be spread on, some will be spread on this side. So this is minus, so it's going to pull this plus Q. So this will be distributed like this. Minus Q over 2. So these are the minus surfaces. And these will be the plus surfaces. Okay, so now when we do the integration from point A to R1 to R2, of course inside is E is 0, and from R2 to B, I'm going to get contribution from here for electric field. here will be sigma over epsilon naught to epsilon naught from this plate, and from this plate is going to be plus sigma over 4 epsilon naught. In here, electric field will be very exactly like that, sigma over 4 epsilon naught from this plate, and from this plate is going to be sigma over 2 epsilon naught. So this turns out to be this times, so when I do E dot dl, I'm going to get this times d and this times d. So I'm going to get 2 times sigma over 2 epsilon naught plus sigma over 4 epsilon naught. And so that's going to times d. So this is going to be sigma d over epsilon naught 1 plus half. So 3 half sigma d over epsilon naught. And sigma is a, q over a, and this thing is c0, 1 over c0. So c is, so 1 over c is 3d over 2a epsilon naught, which is 3 over c0. So c is c0 over 3. So for r, I'm going to get 3. Oh, that's not correct. That's not correct. So I have a 3 over 2c0. So c is 2c0 over 3. So this is that answer. So R is that answer. So we have ruled out this guy and this guy, but in the remaining, R was again not going to rule out. So we really have to do the S to figure out, okay? So I'm going to erase it and do the S, okay, very similarly. Okay, so the final decider is now we're looking at. So again, we're going to put a plus Q on this, but because this is connected over here, this plus Q will distribute over all these surfaces, and because there's a minus Q over here, it's not going to distribute on the other side of this. So this plus Q will be on this will be Q over 3, and on this end minus plus Q over 3, and on this surface plus Q over 3. Similarly, minus Q on this thing will distribute minus Q over 3 remaining here, and minus Q over 3 over here, minus Q over 3 here. And notice that we won't have anything on this end, and we won't have anything on this end. Okay. It actually doesn't matter what's on that end, but we won't have anything. So we are going to go A to B, integrate. So what's the electric field here? From this plate and this plate only. Other plates don't matter because they are, going through, has to go through the infinite plate. So they don't, those electric fields don't penetrate the infinite plate. So electric field is going to be Q over 3 A 2 epsilon naught from this plate plus Q over 3 times 2A epsilon naught from this plate, and this just going to be Q over 3A epsilon naught. That's correct. I'm going to do E dot dl for the V. What we're going to find out, or minus V here, okay? What we're going to find out is Q D over 3A epsilon naught. So C is going to be 3A epsilon naught over D, which is 3 C naught. So that's not the case. So this is the case. Okay, so that's it. This was a pretty long problem. There's a lot of other ways of doing it. Some people do like, okay, are these plates in parallel? Now here, the only way you're going to get this situation is if you can think of, in this situation, all plates are in kind of parallel. So, I don't know how to explain that other than doing this. Okay, so this is as if there are 3 of these guys in parallel, and so this is A and this is B. Now that's the only way we're going to get 3C0. So there are ways you can think about it, but I find this to be much easier way to look at it. Okay, and it connects with the basic definition over the how to think about capacitance. All right, so much for now. So I'll see you in another video. Bye.